Plimpton 322 is a famous Babylonian math artifact, and on it is a list of Pythagorean triples. I want to show you how they might have come up with those Pythagorean triples. What they do is they start with a number. For instance, 8 over 5. Now, 8 over 5 is a special number to start with because 8 over 5 is 1.6, and the reciprocal of 8 over 5 is 5 over 8, and 5 over 8 is 0.625. So they are both terminating decimals, and that will only happen in base 10 if the factors of the numerator and denominator are just 5s and 2s. So 8 over 5 is a number that this will work with. The rule is that the big number c is going to be x plus 1 over x over 2, and a is going to be x minus 1 over x over 2. When I make x 8 over 5, I get 8 over 5 minus 5 over 8 divided by 2. Sorry, that was minus. Became 0.4875. Whereas if instead I add 8 over 5 plus 5 over 8 and divide that by 2, I get 1.1125. Now, the next step is to move the decimals over so that these are integers. So turn this to 11125. Basically multiply the answer by 10,000 and 4875. These two numbers are numbers from are two numbers out of a Pythagorean triple. So if I call C 11125 and A 4875, I can calculate out B by doing the square root of C squared minus A squared, and B ends up becoming 10,000. And this is a Pythagorean triple. But if I have a calculator, I'm able to get a smaller Pythagorean triple. If I take these two numbers, 4875 and 11125, I can actually reduce this. Now, it's not that obvious that 125 goes into both, but if you have a TI calculator, you type in the fraction, you put the small number in the numerator of a fraction, and the bigger one in the denominator, and push math, enter, enter, and it will reduce this to 39 over 89. So that means a better Pythagorean triple would be A is 39, C is 89, and B, if you calculate out the square root of 89 squared minus 39 squared, you'll get 80, which is the nicer Pythagorean triple. So that's